Hey, this is Brock Lemires, and in this video I'm going to introduce the concept of engineering ethics. Now, to begin, ethics is something it's a large field of study, and it's not something that you can learn in one video. I mean, there's tons of books that are dedicated to ethics, and there's entire classes on it. So what we really do with engineering ethics is we try to talk about it throughout the entirety of our curriculum so that we can see how it kind of is applied in different circumstances and helps guide our day-to-day decisions. So in this video, what I want to do is I just want to kind of introduce the topic, and I want to try to kind of motivate why it's important to engineering, and also gives a brief introduction to kind of the strategies that we use in engineering to actually apply ethics. So let's start with when we think about like why is it important in engineering, let's start talking about what an engineer is. Okay, so remember, an engineer is someone who takes knowledge that is created by the sciences and develops systems or technologies that benefit society. Okay, and so you think about, for electrical engineers, the electrical grid and our communication networks. Those were technologies that came from some basic scientific knowledge that was discovered, and then we built a system that then today benefits societies. And so we create and sustain this technology for our society. Okay, and so it's awesome. So then what is ethics? Okay, so ethics is a discipline that's concerned with what is morally good or bad, and or said another way, what is right or wrong, and what's right or wrong of an action, a way of life, or a decision. Now, you can see right away, scholars have studied and debated and contemplated morality since the beginning of humanity, right? So it's not something that an electrical engineer is going to try to contribute to, but what we want to do is we want to try to take what ethicists and philosophers have basically come up with and try to help guide our engineering decisions. Okay, so what makes it really challenging is that what people think is right or wrong isn't always the same. Okay, it's not, laws are easy, right? Laws are, you break the law, that's wrong. But we're talking about things that aren't illegal. They're just basically decisions that some people think are right, some people think are wrong, and everybody has a different code of ethics or different moral code based on basically your society or the corporation that you work with or the culture that you're from. So it isn't as cut and dry as you might think when you start thinking about right and wrong. Okay, so why is ethics important in engineering? Quite frankly, public safety. Okay, so that's first and foremost what we need to take care of. We are building systems that are huge. Okay, you think about the electrical grid. This has the capability to kill people. I mean, just flat out. Dams. I mean, think about a dam. I mean, think about how amazing it is that you can hold back so much water. And if you don't make that, if you cut corners and make unethical decisions that might put profit over safety, you can see that you can cause a lot of harm to people. So public safety is paramount in this. But engineering ethics today transcends that a little bit. Public safety is number one, right? But number two, we start seeing that some of the decisions that engineers make can kind of skew solutions that might work better for certain parts of our society compared to other parts. And so today we talk a lot about, these decisions and how we might have some sort of bias toward our particular view of the world. And so what engineers have to do today is they really have to start thinking about society as a whole and start thinking about all the citizens within a society and thinking about, how do we make sure that we don't kind of design something that precludes one part of society from actually benefiting from that to the advantage of another part. So public safety, and also just kind of the whole comprehensive contribution to society as a whole. Okay. Now, let's think about how ethics influence our engineering decisions. First and foremost, engineering decisions are complex. And so you say, well, yeah, of course, they're complex. Engineering's hard. Well, if you really think about what complex means, there is actually a definition to it. So in engineering, a complex problem has many variables. Okay, it's not just y equals mx plus b. I mean, you're talking about many variables that change with time and change with space and change with a lot of different factors. But what really categorizes engineering decisions today is that there's usually no right answer anymore. Okay, we learn engineering problems like we solve a circuit and there's an answer. But when you go to like build a system, what happens is that you notice that there isn't like a solutions manual. Okay, it is always a trade-off of a lot of different variables. And you can think about it as there's a lot of right answers to get to the end. So you can have a lot of different designs and create a lot of different systems that actually achieve what you're able to accomplish. And so what you're really trying to do is trade off these things to try to find the optimal solution. And optimal might mean different things to different folks. So that's why engineering decisions are what we call complex. And today's problems are even more complex. So in the beginning, when you started thinking about, engineering solutions, there was this thing called the engineering management or pyramid or design pyramid. And there were three variables that you would have. You'd have the scope, which basically means the functions of the system. So what is this system actually going to do? And then you had time and you had cost. And you traded these off against each other. So for example, if you had a new phone and it had every feature you could ever think of, it might take 10 years to develop and cost, and each one would cost $10,000. So you would go, oh, we can't take that long to develop. We can't have it cost that much. So we'll de-scope it. So we'll remove features until the schedule gets in line with what we want and the cost gets to where we want. And then if somebody adds a feature to it, then you add time to the schedule and cost to it. And so this is kind of the standard way that engineers were trained. That's how I was trained. Now you think about today, it's like, holy cow. So that design pyramid or project management pyramid fits within a technical constraint. And if you think about all the other things that engineers have to deal with today, you have to make sure that the system that you're designing or you have to look at the societal impact of it. So your goal is to benefit society, right? So you got to make sure that you don't take away benefit from society or harm society. And this goes back to the whole thing of trying to design systems that benefit every citizen and not just a subset of the systems. And so societal impact is something it's foreign to engineers from my era. Okay, so this is something that you're dealing with today. And then also there's the economic impact. And so what's interesting about economic impact is that it's different than cost of the product, right? It's not the phone, but it's like the economic impact of society. So when you're going to build this system, where is the system going to be manufactured, right? And what's going to happen when you make that decision is that all of a sudden there'll be an economic impact on a certain area of the country due to the manufacturing. What is that going to do to the economy of that city? How is it going to change it? Is it going to be better? Or are you going to turn the city into an industrial district and stuff like that? So there's an economic variable here. And then there's the environmental impact, which is you can't harm nature. If you look at some of the solutions that we have right now from engineering, they harm nature, right? I mean, we're burning coal like crazy to boil water to make generators spin. That's hurting the environment. And we just kind of thought, oh, the air will take care of all this smoke. And it's like, now it's not taking care of it. We're producing too much. So you have this whole environmental impact of it. And so you got to make sure that your systems don't harm the environment. And then that bringing all this together kind of is this sustainable design process where you're no longer able to make design decisions that are just these open-ended, who knows what's going to happen after this system, is done. It's like, no, you got to be able to sustain the system and then also obsolete it in a way that doesn't leave harm to both society, the economy, and the environment. And if you think about it like that, then you start thinking about, environmental is easy, right? It's like if you're going to build a copper mine, you can't dig a big hole in the ground and just walk away from it, right? So somebody has to fix that. But also, if you're going to build an economy for a particular city, what's going to happen when you decide to not have that manufacturing plant there? So you can't just walk away from a city and then all these jobs disappear and just, the whole city just collapses. So there's a lot of variables going on here, and it's kind of challenging. So engineering decisions, it's a balancing act. And let's go back now to ethics. Okay, so now how are we going to do this? How are we going to balance all these decisions in the or framed within the whole concept of making ethical right and wrong decisions? Well, let's think through this a little bit and see how it can become even more interesting challenge. So first of all, when you think about ethics, we're not talking about laws. Okay, so everybody understands if there's a law and you break it, it's illegal. And even when you have different countries that have different laws, they're easy to follow, right? You find them, you don't break them. Okay, so those are actually kind of easy. But so when you talk about ethics and how it impacts engineering decisions, what we're really talking about is, the hundreds of decisions that you make in a day, the 100 actions that you take in a week that guide your whole design philosophy or your design process, okay? And so these decisions aren't illegal, right? These are all legal things, but it's just kind of like how do you make those decisions and what kind of influences you? And this really comes down to, it's usually a culture, right? So it's a culture of, the business that you work for, and it's also a combination of your own moral code, right? I mean, it's your background that brought you to this time and place. And so here, let's look at a really simple, kind of a silly example to kind of illustrate this point. And so let's think about a pencil at work. So you get a job for a company, and you're an employee, so they're going to provide you everything that you need to be successful at your job. So that's a desk and a computer and a chair and paper and pencil and staplers and everything. So you have all this stuff at work. And the question that is posed is, can you take a pencil from the supply cabinet and take it home? Okay. And the knee-jerk reaction that most people have is, no, that's stealing. And then you sit and you think about it, just not even for 5 seconds. And all of a sudden people will start realizing that there's more to it, right? It's like, well, wait a minute. I do work at home, right? It's like I'm a salaried employee. I'm always kind of working. So when I'm at home, if I'm working on stuff that's for that company, shouldn't I be able to use that pencil at home because I do write down notes and everything? And it's like, well, yeah. So then you can kind of convince yourself that it's like, yeah, it is okay to take that pencil home, and yeah, you might use it for personal use too. But it's kind of silly it's a waste of your time to like have a pencil at home that's for your personal, and then you have a work pencil and stuff like that. And so even something as simple as a pencil kind of illustrates that there's this gray line of like, it's not really right and it's not really wrong and it's not illegal, but how do it's what makes you make those decisions? It's what's your background that gives you that, decision making ability. And then if you kind of go back to the knee-jerk reaction of like, no, it's illegal, then you might go, well, why don't, if it's gray zone, why don't we just make a rule, right? Let's make a law or a rule within the company that you cannot take home a pencil. Okay, let's just make it really clear so that engineers don't have to worry about these gray decisions. Well, if you expand that, what you realize is that you would have to have a rule for almost every single situation that may ever arise. And there's so many rules that would be needed to govern all the thousands of actions that you take each year and every decision you make that it becomes impractical, or it is impossible to make rules for every situation. And so this now is kind of this ethical framework that we live in. And a lot of people will call it like micro ethical decisions. So it's not really like you get faced with this thing where it's like, you need to design, your boss tells you need to design this and it's gonna kill people and you need to do it because we're gonna make a lot of money, right? Those aren't the type of situations that we're faced with. It's these just hundreds of very minor situations where you tend to favor one direction versus the other, and it's because of a culture potentially at your workplace. Okay, so this is I know it sounds scary, but it's like, this is just the motivation for why this is a complex and very important subject. Okay, so it's like, I can't do this, right? I mean, I'm learning electrical engineering. It's taken me 4 or 5 years to get through the bachelor's degree. I can barely make it through all this complex math. And now you're telling me, oh, and by the way, you also need to be a philosopher, okay? And you also have to have, understand morality like every philosopher has ever understood it since the beginning of humanity. It's like, okay, no. This is something where you use knowledge from other fields to help guide you. You work with other people from other fields to help guide you. And we have also come up with tools and techniques in order to help you, navigate these situations. Not just you, all engineers. So number one, we start with the code of ethics. Okay, so engineering has a code of ethics that helps us guide our decisions. Okay, and within engineering, the overarching code is from the National Society of Professional Engineers, and it's very interesting. It's what you would expect. Within electrical engineering, we actually have a professional society. It's called the International the Institute of Electrical and Electronic Engineers, IEEE, and it has its own specific code of ethics. IEEE happens to be the largest professional society in the world, and so they felt like they had to come up with their own code of ethics, even though it's very similar to the other ones. But just to go through it, there's like 11 steps, and it really is common sense. It's stuff that you would think anyway, but it's if you write it down and say, and everybody agrees that this is what we're going to do, then it kind of provides like this mini law book for you that you can always consult with. Okay, so really quick, let's just go through some of the highlights of it. So, we are going to hold ourselves to the highest ethical and professional conduct by agreeing to the following. We will always hold safety and health of the public paramount. We will always avoid conflict of interests. We will be realistic in stating claims. We will reject bribery. We will we'll improve the understanding of individuals. We'll try to educate our stakeholders so they understand what we're talking about. Okay, we'll maintain our own technical competence. So it's not okay to just get a bachelor's degree and then say I know everything in the world about electrical engineering. You have to continually improve yourself as technology changes. You have to get peer review of your designs. So get honest criticism of your own decisions. You don't engage in discrimination against anybody. You don't do malicious actions to injure other people or injure their reputation. And we also agree to assist each other in our own professional development. So we're in other people's designs. Okay, pretty common sense. This is almost like don't murder people, right? Everybody agrees, and you think, why would you have to ever write that down? It seems common sense. Well, it's pretty powerful to have something written down because it gives you something that you can refer to when you're faced with situations, and you can always come back to this and say, hey, the code of ethics helps guide me. Okay, so that's the first thing that engineers get exposed to when it comes to ethics, and it's a great thing. How do you learn about ethics? Okay, this is an interesting thing. So if you're taking if you're pursuing a degree in electrical engineering and you're learning about circuits and all this stuff, then you have kind of this whole ethics thing, and we have this notion that there's like no right or wrong, right? Correct. And it's kind of true, right? So it's all these little micro ethical decisions that people make that compound on themselves. So what we've learned is that the best way to understand ethics and to learn about it is by case studies. And so when you take classes in ethics, you can talk about moral frameworks and decision-making frameworks and how they integrate. But really what you like to do when you learn ethics is you look at other situations that people have been into or have been in that resulted in some problem. Okay, so a classic one is like the space shuttle Challenger, where the O-rings caused it to explode. And so there's books and books written about this, and what you see in it is that it wasn't like this one moment, right? It was just a series of decisions and a culture that kind of swayed certain decisions from being made or voiced, and it was a whole lot of small things that ultimately led to a catastrophe. And so and when you look at that, you can kind of look at patterns that emerged and understand it's like, well, yeah, I can see it happening, right? There wasn't one moment, but you can see the patterns that happen and why it ended up this way, and you can try to model new cultures after that, new company cultures. Another one is like the Volkswagen scandal. So this is where Volkswagen actually built software into their cars so that when they did emissions testing, it would know it's being tested and it would put the car into a low emissions mode. And then as soon as it got out of the test, it would crank back up and put out more pollution. And so you think it's like, wow, but that is just flat illegal. Like that was breaking the law. But again, it wasn't like there was one evil business person in the company that just says, I'm going to make this happen. It was a whole lot of things and a lot of different people where this culture kind of shifted the balance of decision makings toward an end result that ended up being illegal. And so by looking at that, you can start identifying these patterns earlier and understand how these things actually happen. Because when you hear about them, it just like a really quickly, you're like, I can't believe that happened. But it's only when you really study the whole process and the history of it that you start seeing these patterns. Okay, finally, we get down to applying ethics. So once we've talked about why engineers are important to society, why our ethical decision making is important. We have a law, we have the laws, we have the code of ethics. We have all this stuff. We learn about it using case studies. And finally, you get to be an engineer and you get to practice this and you get to apply ethics. So it turns out that we have a step-by-step guide that helps us apply ethics, and there's different versions of it, but I'm going to show you one that's called the 7-Step Guide from Ethics and the University by Michael Davis, 1998, and it helps us navigate these ethical issues that come in engineering. And this is just one application of one version of this application, but it'll kind of show you that you're not just alone, right? You're not just like, I hope I make the right decision. It's like, no, this isn't, we're going to apply a process to this. So step one is, if you are faced with something that doesn't feel right, you state the problem. Okay, why does this make me uncomfortable, and do I have a conflict of interest that's making me feel uncomfortable? You should never feel uncomfortable as an engineer. Okay, if you are working at a place and you're uncomfortable with something, that is not normal. Okay, you need to stop and go, what is happening? Why do I feel so uncomfortable about this situation? Engineering it's supposed to be fun, right? I mean, you're really doing some important work, so it's not supposed to be uncomfortable. So if you ever feel uncomfortable, you got to stop and just say, what is going on here? And you state it. You write it down. Say, why is this problem making me uncomfortable? And so that right there allows you to say, I might have an ethical situation. The next thing you do is check the facts. Okay, a lot of times people feel uncomfortable because they don't have all the information. And if you don't have all the information, sometimes you don't see the big picture. So the next step that you do, number 2, is you get more data. So you check all the facts and try to get the background. And almost always, once you have a situation that makes you feel uncomfortable, if you're able to get a bigger picture, more information about what's happening, most of the times you realize that it's not an issue and you don't feel uncomfortable anymore and you're able to proceed. However, if you don't, what you need to do is say, I might have something going on here that's an ethical dilemma. And the next step, number 3, is you need to identify relevant factors. So you're gonna sit here and you're gonna go, I'm gonna list the people and the stakeholders involved, and I'm going to look at the code of ethics, and I'm going to look at these things, and I'm going to start thinking about, okay, are we really violating the code of ethics? Okay, who might be doing it if it's not you? And are there people that might have a conflict of interest that would be leading them to violate one of the code of ethics statements? Okay, so then once you get that down, now you kind of have more, have it like a case for what's happening. Then you problem solve. So number 1, develop a list of options. Okay. First of all, avoid dilemmas where you have no win situation. Every situation is a winner. Okay. So you gotta have solutions and be creative. Okay. So it's like, who can you go to for guidance? Seek mentoring on what to do here. Come up with different ideas on how you could resolve this without it being just a horrible situation where there's no way out. And then now that you have solutions, you can start proposing them. Okay. Then what you got to do is take these tests. So we call testing our options. Okay. So as you think about how to proceed, there are a variety of different tests that have been developed by people that allow you to see if these ethical situations are real and if your solution is good. And so there's the harm test, the publicity test, the defensibility test, the colleague test, and the organizational test. And these are things that you apply personally based on your own background. So the harm test, for example, is, does this option do less harm than the alternatives? Okay, and so your solution you've come up with, is it better or is it actually worse? The next thing is the publicity test, and this is interesting. So if you pursue one of your options, how would it make you feel if it was published in the newspaper or the TV? So the general population saw this. Would you be embarrassed? Okay, so if your family saw this, would you be like, wow, I can't believe that I did this. I can't believe I pursued an option that was a solution to this issue, or let the issue proceed. And my family looks at me and they're very disappointed. How would that make you feel? If you're able to have this be publicized, like on the front page of the newspaper or on on TV, if you feel okay, then that's good. Okay, that's a good thing, because it takes a lot to be able to say that. The other one is the defensibility test. So let's say you got called before Congress or called before a judge, and they said, you need to defend this action. Actually, it'd be probably more like Congress, but you need to defend this action. Could you actually defend it with logic? Okay, could you actually show why you came to this decision and defend what ultimately happened? The other one is the colleague test. So what would your coworkers or other engineers say about your option? Okay, what you ended up doing? Would these peers that have the same training as you, would they understand it, or are you doing something, pursuing an option that is just so random that they would be like, wow, this is no good. I mean, this is horrible. And then this is the other one, is does this option make the match the mission and the standards of my organization? Another way of saying this is the culture of the organization. Is this decision in line with the culture of my organization? Okay, and then you got to make a choice. Okay, so if you are in a situation where you recognize something's wrong and you are going to propose a solution, and let's say that it doesn't work, and so it's rejected, and you know you're going down a path, you have to make a choice. Your choices basically are you going to stay in the fight knowing that you're going to be forced to do something wrong, or are you going to pull the ripcord and bow out? We have laws called the whistleblower law that allows you to basically make a claim against your organization without repercussions. And so you can always quit your job and file, or you don't even have to quit. You can always file a whistleblower claim and you remain anonymous, but you need to make a choice at some point. Okay. And then finally, the last one is review the process. What precautions can I take to avoid this next time? So you're not done with engineering as soon as you resolve an ethical situation. You're an engineer for your whole career. So what can you do? What choices can you personally do to change an organization you're in, to choose an organization that you want to be part of, to maybe influence laws? And then is there a way to get more support for yourself next time? Okay, so this is pretty complicated stuff, right? But there is a process. It's not just you alone where you have to make some really very difficult morality choice. There are the code of ethics, there are processes, there's a whole system of framework on how to learn about how to do this stuff and how to recognize situations. And so that is an introduction to engineering ethics. Hopefully it kind of motivates the need for this, and it will kind of explain why you're going to see so much of it as you continue to study electrical engineering. All right, that is it, and we'll see ya.